organising this. Perfect timing. As we see more and more nuclear projects developing, and whenever you're talking to people trying to develop a nuclear project, the first question is, how quickly can we get clearance from the Commission? That's always the first question. And that goes to the heart of what we're discussing today. So we have a number of basis materials on which to discuss. One is the Commission guidelines on CfDs, obviously. One is the electricity design reform. One is the CEAG, the state aid guidelines on climate, environmental protection, energy. And one is the CSAF, the Clean Industrial State Aid Framework. And if you really don't know what to do one evening, read all of them, and you will learn the following. When you do a nuclear project, if you want a state aid, you have to do it by two-way CfDs. And that's about it. Okay? There's not much more in all of these documents. That's about it. And so what the real guidelines are, at the end of the day, are the individual decisions that the Commission is taking on these CfDs that we're going to talk about today and try and unpick in a little more detail on how you actually get that done. Okay? So we've got three great speakers, Marcin Kamiński, Assistant Professor at the University of Warsaw and the Regulatory Risk Manager at PEJ, the Polish SPV that has done the first nuclear state aid decision and is doing the first nuclear project in Poland. We have Guillaume Desorby, the Senior Lecturer at Amiens and a partner at EY Law in Paris. And then we have Fabian Roques, the Associate Professor at Paris Dauphine and a partner at Compass. So you're an economist? You're an economist. Excellent. It's always nice to see a strange. They're going to cover three things. Marcin is going to cover the reference price issue. Guillaume is going to cover the question of modularization of nuclear, modulation of nuclear, if that's right. That's going to be your focus. And Fabienne is going to talk about the economic aspects of these issues. The idea was to get Marcin to speak first. And being as he's just walked through the door, and giving him absolutely no time to prepare himself whatsoever, Marcin, are you ready to jump in already in order to talk about the reference price issues?
It's called perfect time.
Excellent. So, Marcin, as you catch your breath, the floor is yours. Do you have slides?
No.
You don't? Excellent. My goodness.
What's it called? How it works. Hi. Well, apologizes for being just in time. I'm running from the meeting from DGNR. It's good that it's not so far from here. Yeah. So, in terms of the reference price, so I wanted just to underline the most important issues or element from the perspective of the designer. So once you design the reference price for a nuclear power plant, what's important? And the first thing is the perception. And typically there are two perceptions. So either you treat it as a standard procedure or standard element, and you would like to avoid any mistakes, or you perceive it as an opportunity to address certain market failures or enhance certain market features. And I think nuclear is well suited to playing the offense, so to try to provide as much benefits to the market as possible from the design of the reference price. So this is the first element. And then the second, it's not the perception, but the assumptions. The first assumption is that investors are risk averse. They would play according to the rules you schedule. So because the reference price in its principle is the price to which we compare the strike price. The reference price should reflect the market price, and that's the way to steer the market operations and the market behaviors of market participants. And if you create it as for example, day-ahead market price, then all of the investors will be inclined to operate only on this market. Because diverging from this market, selling on the other markets, puts your revenues under risk. And that's what typically as an investor, especially for such a long-term investment, that's what you avoid. You avoid any risks. If you play according to the formula and it ensures stable revenues, that's what you will do. That's the assumption from the investor's perspective. You don't want to take any risks in this respect. So this is the first assumption. The second is that they will play the game, but if there is a possibility to optimize or to maximize, so if there are any flaws, investors would use it. That's what we've seen previously in the design of the contracts for difference for renewable sources, where there were some gaps, some lags in the reference price design, and the investors were ruthless and they just used those gaps. So this leads me to the third part, so the design itself. So in order to use this opportunity in playing the offense, I reckon that the best possibility is to address current market failures, which, according to ACERS, are the same in all member states, and they include forward market. So nuclear power plants are well suited to operate on the forward market, to sell electricity in year-ahead contracts or even with the longer duration. I think there's the opportunity just to use it. If we see the guidance of the European Commission, that's exactly what's said in the guidance, that nuclear power plants are well suited to steer, to operate on the forward market, and that's what can be necessary, what can be mandatory for nuclear power plants. It's not the case for intermittent sources, which is obvious because of their technological aspects of those electricity sources. Of course, it does not mean that one cannot include also day-ahead markets, intraday markets, but the forward markets, this is the perfect opportunity which can be used by the designers. Then there are more detailed elements. So how do you calculate ex ante or ex post? Typically ex post is better because you avoid gaining risks and knowing beforehand what will be the reference price and gaining against this reference price. There's the question of the reference period. So when we calculate what's the settlement period and what's the maturities and how long do we calculate it. The longer the better in this respect, in order to avoid any short-term gaining in the system. The longer the better. I think the yearly average, this is what typically can be done, but in other cases we see that reference price can be calculated each half year or even each quarter. So it's up to the member state to decide, definitely not on a daily basis. And then third element is whether this price is exogenous or endogenous, saying that whether this is a market price, so this is an average of the market, or this is the average of the operator of the nuclear power plant which receives on the market. And definitely to, in order to incentivize operators to beat the market, it's better to set it exogenously, so as an average of the real market price, which provides obvious incentives just to try to beat those price, and all of the gains will come down to the investor. So there's, and of course there are more details into that, but I think those are the four crucial elements in this respect. And I think that whereas there's lots of literature on the more detailed elements, especially stemming from the experiences for designing reference price for renewable sources, there's not so much literature on the reference price on for the nuclear power plants, and definitely there's this novelty, new element of including forward markets in the calculation of the reference price. This is the case in the case for the first nuclear power plant in Poland. It's been included, so this is the first case in the history of state aid proceedings, and right now we've seen that in new support schemes notified by France, but notably by Czechia, reference price is explicitly included. So I think we are those elements, those features are being recognized by the member states, and we might see a common pattern in calculating the reference price or in designing the reference price. Having said that, it's up to the member state to decide, also based on its market characteristics and how it functions. Okay, so many thanks.
Thank you, Marcin. I think before going on to the discussion, we'll go through the three presentations. So I think the second one is Guillaume. You're going to talk to us about modulation and flexibility.
Thank you very much, Christophe. Regarding modulation, the idea, nuclear and modulation, the idea is to go into the paper of the Commission, the guidance of the Commission, and to have some insights from the French experience regarding modulation. So just to set the scene and to recall what is a contract for difference, the definition is given by the regulation 2024-1747. Those contracts exist since quite a while now, but there are huge reflection around this new context regarding the financing of nuclear. As Marcin was mentioning, the key issue is the reference price and the strike price. And it's a risk-sharing contract in a way. The idea is to protect the operator against the volatility on the market. And therefore, we agreed upon a strike price and on a reference price, and then depending on the fact whether or not the reference price is higher or below the strike price, you will have payment in a way or in another way. So if the strike price is higher than the reference price, the operator will be paid by the counterpart of the contract, and if the reference price is higher than the strike price, the payment will go the other way around. One of the risks of those contracts highlighted by the Commission is what we call the produce and forget phenomenon, which means that the insight of the producer, of the generator, is to produce as much as possible because he will always get the strike price, whatever the level of the reference price will be. And this can be a risk because it does not take into account the state of the market. The new element regarding the regulation that has been adopted in 2024 is first that it includes nuclear. So now the EU legislation says that direct price support scheme must take the form of a two-way CfD, and this includes nuclear. And the text, the regulation also mentions that the design of those new contracts must take into account the participation of the operator on the electricity market. And the idea is to incentivize the operator to react to the market. And in the regulation, and in the preliminary remark, in the considerant, they mention that when the electricity price is below the operational cost of the plant, the operator should be incentivized not to produce. This has been this issue has been developed by the Commission in the guidance. The guidance, which has been published in December, And one of the key messages of the guidance, it's not the only message, but one of the key message of the guidance is to try to find a solution in order to incentivize the operator to react to market prices. The difference between nuclear and renewable is that nuclear has a marginal cost that is represented by the cost of the fuel. So it can be 8, 10 or whatever euros per megawatt hour, which is different from renewable. For renewable, we consider, the Commission says, the marginal cost of renewable energy is 0. So this makes the difference is that the difference is that we cannot just say when the price becomes negative, then the operator should be incentivized not to produce, as it is the case in the renewable and as it is defined in the guidelines for state aid for energy, environment and climate of the Commission of 2022. Here it's a bit different because we have this situation where the price can be below the marginal cost of the plant, and here the Commission say when the price is below this operational cost, then the producer should not be paid for the production that is produced by the plant. So the idea is that the operator should be incentivized not to produce. And then, of course, it may represent a risk for the operator, because if we have important period where prices on the market is below the operational cost of the plant, of course, it's a risk for the plant, and the Commission comes up with a solution which is a payment for independent of the production of the plant. So that's the main message of the guidance regarding nuclear flexibility. And of course, when we come from France, nuclear has important history, and modulation has become one of the key topics of the past few months. The Prime Minister, in one of his speeches at the French Assembly, recalled this question of modulation. Modulation, since a few decades now, has been a topic that was discussed among experts, like, for example, about the ARENH, or for French supplier, or big industrial consumer. But it was very unusual to have discussion of modulation for example, in the Parliament. So it was quite a signal that this topic was becoming a huge topic in France. When you look at EDF report that has been published in 2026, you can see the level of modulation of the French plant for the past 25 years. So it's in terawatt hour. So if you add all these modulation, it represents a huge amount of electricity. And another element that shows that modulation has become an important topic, at least in the French landscape, is the number of publications in the past few months around modulation. The TSO, the regulator, the Cour des Comptes, and of course the report of EDF on this topic. What do we learn? So we learned first that we have two different types of modulation in France. The first one is what we call load following mode. It's the historical way of modulation in France. In a way, and the reason of this modulation is the sizing of the fleet. And the French regulator recalls that we have a fleet of 60 gigawatt, when the level of demand is more around 50 to 40 gigawatt. Of course, this enables France to export important volumes of electricity, and that's what has been done since now 50 years almost. And it makes the French nuclear fleet in the center, in a way, of the European market, in a way. So a few remarks regarding this first type of modulation, load following. First, from a semantic perspective, we see maybe a shift. We used to speak of load following mode, and now the regulator in its report is more using the economic modulation. I don't know if it's only a semantic difference, or if behind that there might be a kind of difference between a modulation that is chosen by the operator, organized by the operator, and a modulation that is imposed in a way to the operator because of market price volatility. The second remark is that this kind of modulation first was the result of insufficient demand on the French market compared to the size of the fleet. Now, this type of modulation must take into account the development of renewable energy, because it contributes to lower the prices on the market. So if you have a situation in which you still have a low demand and you have more and more renewable electricity coming on the market, of course, this becoming quite a problem for the operator, because the need for modulation increases. And that's why the French regulator and the president of EDF, also in a letter to the Cour des Comptes, mentioned that maybe we have reached in France a level of modulation that could not be higher, or at least this can create some difficulties. So that's the first modulation type, and in a way this is quite similar to what has been described, what we can learn in the guidance of the Commission. The second type of modulation is a modulation for what is called fuel saving. Here, the idea is a bit different, is to say that when you put some fuel into the reactor has a stock of fuel, and that will enable the producer to produce until the next maintenance. And then the operator will try to make the most of this stock, and he will in a way operate the plant a bit like a hydropower reservoir, in a way. And this is still in the idea of the guidance of the Commission, because the idea is to value as much as possible the electricity. So it is to produce when the price of electricity are the highest, in a way. And that that type of modulation is in quantity. If we read the report of EDF, it's about the same. At least I think it's for 2025, the same amount. But what is the reason behind this second type of modulation? The first reason is the constraint that are applied to program, to plan the maintenance of the plant. In a way, the operator has to have its team available, but also all the partners. And in the report of the French regulator and in the report of EDF, it is very clear that those constraints make it very difficult for the operator to change, to shift the time of the planning. So once the planning of the maintenance has been decided, it's very difficult to change it. The second reason is that the fuel in the plant can be consumed more or less quickly than expected, and it also depends on the first mode of modulation. The more you will have to modulate because of load following, the more complex it will be to plan the second, the maintenance, and then this could require some fuel-saving modulation. And the third one is an example of the COVID period. Because of COVID, there were some difficulties in order to plan, to schedule the maintenance, and some of the plant had to be modulated in order to save some fuel for winter time when the prices are the highest. What is interesting is that the French regulators say, in fact, the plants are always operated through what we call opportunity cost or value of use, valeur d'usage. But sometimes, if the fuel enables the operator to go as long as up to the maintenance, then the opportunity cost would equal the operational cost. But it may not be the case. For example, if you need to save some fuel because you don't have enough fuel to run at full capacity up to the maintenance phase, then you will take an opportunity cost that can be higher than the operational cost. In the guidance of the Commission, we don't find this kind of modulation. But there is one sentence mentioning the opportunity cost. And at the end of the document, you have the definition of the opportunity cost. So here, we don't really know if it is clear from the Commission that we have this second type of modulation, and this is something that can be expected from the Commission. The Commission at some point mentioned that we expect from the operator to produce more when prices are the highest, in a way. And this is exactly what this type of modulation is doing. And but this raises two interesting questions regarding the definition of operational cost. In the decision, in the public decision of the Commission that we'll discuss in a minute in the second round table, the operational cost of the plant is not defined. We don't know if it's only the cost of the fuel or if it can be something different. Let's take two examples. For example, in the EDF report, we can understand that for security reasons, when you approach the maintenance, you need to empty the reactor of its fuel. So you will produce 24 hours a day, 7 days a week. And then you will produce, in a way, at any cost. So even if the prices becomes negative, you will need to produce. Of course, this is not this question is not dealt by the Commission in the guidance, so we don't know if this risk for the operator can be covered by the CfD or not. The second element that could be that could raise question is the other way around. Prices are very high on the market, but the operator believes that the prices on the market will be even higher in a few months or in a few weeks. So he will decide not to produce in order to save electricity for other period. This can lead, if we look at the CfD independent from production, this can lead the producer to pay its counterpart because the price on the market is higher than the strike price. So, in theory, he should be producing and then earning money on the market and give back the difference between the strike price and the market price. And on this, it's not very clear either from the Commission if this risk can be covered by the contract. To conclude, just a few remarks regarding REMIT. Of course, we expect, the Commission expects the operator to react to market constraints in a way. That's exactly the purpose of REMIT guidance on wholesale markets that applies to wholesale market. And on that issue, at that time, we don't find much in the Acer guidance regarding this kind of flexibility and modulation. In fact, the topic is maybe broader than just modulation of nuclear. It's how to operate devices or installation through the value basis or opportunity cost, because it's also true for water reservoir, but it can also be true for batteries or things like that. Two questions are important for operator to make sure to comply with REMIT. It's what information should be published, and how can I be sure not to be in a market manipulation in a way. So nothing in the guidance of Acer. So maybe this topic maybe needs clarification. The French regulator has started to tackle the issues. We have in the different report a few information on what could be published, what should be published, and what is not market manipulation. And at this stage, for example, the level of price set by the operator for valeur d'usage of its reactors has always been considered as reasonable in a way, but we don't really know what kind of expectations the regulator may have in order to secure the operation of the operator. Thank you very much for your attention.
Thank you very much. I'm sure everybody has lots of questions, but we'll, I guess, keep them. So, Fabienne, thank you very much for being here. We're looking forward to hear about the economic aspects.
Right. Thank you very much. Good morning all, and big thanks to the organizers for the invitation. So I'd like to clarify first that I'm expressing my views as an academic with Paris Dauphine, disclosing also my interest, being at the moment appointed to work on the Czech, the French case, and the Dutch case, and having worked before on the Belgium and the UK cases of state aid in nuclear. So that being said, very interesting remarks on the reference price and modulation. These are topics where economists like to spend hours discussing about, right incentives and opportunity costs. I will refrain from doing so. I would like rather to use my time to perhaps as an economist, step back and do three things. First thing, I think it's important when we talk about interventions in a common market to think about the market failures that we are addressing and how the aid package is addressing these different market failures. Second thing, I'd like to highlight a number of trade-offs in designing these aid packages, which I think are true across all of the different cases that I've been involved in. And third thing, I have been involved for 2 decades in the research on what I call hybrid market models in electricity markets, which are, I would say, the fusion between markets and a range of contracting and planning tools. So I'd like to think about the role of these cases in moving forward the debate on these issues. So let me start with the first point. As an economist, what are the market failures we are trying to address here? There are market failures both in electricity markets and in the broader set of capital markets that would prevent a private operator to finance and even have a viable commercial case for nuclear power. These are well known, but I think it's important to set them out so that we understand how the aid package and the different components relate to the specific market failures we are trying to address. So in the electricity market itself, I think it's well accepted now that electricity markets are good at dealing with the short-term allocation issues, meaning how do you decide which plant is running when? This dispatch question is one where I think there is, in the academic community, a broad consensus to say power markets do that well. However, there's one thing that power markets are struggling to do, is to think about the long-term investment incentives in a way that would internalize all of the externalities. For instance, environmental externalities. You could say we have the carbon price in Europe, but that's not sufficient to fully internalize environmental externalities. Or, for instance, security of supply externalities. The value associated with having a diverse energy mix is very hard to quantify economically. The value of having nuclear as part of a mix of low carbon generation is certainly something that many believe in, but very hard again to quantify and certainly not revealed by the markets we have today. So these are market failures in electricity markets. Some have also, and I include myself in it, highlighted the lack, and Marcin mentioned it, of opportunities for forward hedging in electricity markets. The time horizon of electricity markets is 2-3 years, not more than that, if you look at the forwards. So it's very difficult to hedge beyond that time horizon. You have PPAs, but these are not very well developed in most countries. Then that connects with my next market failure. These investments are very large, very capital-intensive nuclear plants, and they take a lot of time to build. And what that means is you are touching with the limits of the capital markets as we have them in Europe and globally. The ability to manage risk, to parcel risk, and to essentially make a nuclear investment bankable is very challenging. My experience I have when the discussion started on new nuclear, for instance, with Hinkley Point in the UK more than 10 years ago, been part of a good number of working groups in the city in London where the financing community was trying to think about a potential bankable model for nuclear. And I think the fundamental issue here is the very challenging, I would say, the very challenge of dissociating the different types of risks that are behind nuclear. Because nuclear is to some extent a very politicized decision. It takes a member state to say yes or no to nuclear, and therefore there are a range of fundamental issues that an investor cannot control if there is not a firm state commitment. And that fundamental issue is one that leads to a net package that is not just going to be about securing the electricity market revenues in the long term. We'll talk about it, that's a CfD. But also de-risking some of the fundamental issues that have to do with the continuity of policy support for nuclear power. And this is where the other elements of the package come in. And last but not least, a lot of that is due potentially to perception and can evolve, meaning capital markets and their appetite for risk and their ability to price different types of risk is not something that is given for granted. And this is where we can hope that there would be some learning and evolution in the next decades, which I think I will connect later on to one of my points. We need to build these schemes so that they can also evolve in the future and be resilient to changes in the future. So that's my first point on the market failures. And I think the summary of that is the market failures are not just limited to electricity markets. And that's why you need a package of aid that is not just limited to the CfD. So let me transition now to how you design such an aid package. And I don't want to go into too many details, but you will see variants of that in different countries. All of these packages build on a two-way CfD, which is starting to be a new normal, and I think that that's useful. But again, this is only one part of the package and can only be one part, and the rest is a mix of either subsidized loans, state guarantees. So this is the other part of the package that for an economist is addressing the fundamental risk question associated with the state support and commitment to support in the medium to long term. On top of that, I think it's important to address some of the key trade-offs that arise when designing a net package. I will ask a few questions here, not necessarily providing direct answers, but hopefully that can foster a discussion. The first question is, how much do you want to de-risk? And in doing so, which are the types of risks that you want to tackle as a state? And I would say as an economist, there is very simple principle here. You should allocate risk to those who are able to bear them the most efficiently, right? What that means is that you should selectively identify which costs and which risks the operator should be subject to, and which should fall on the state shoulders. That's easy to be said, but in practice not so easy, because a lot of these risks are actually interconnected or intermingled, if you want. So the extent of the de-risking is the first question, and there is a broader trade-off. The more you de-risk, the more, I would say, the cost of capital can be potentially reduced, and therefore the cheaper your program. However, let's be careful, because risks never disappear. They are transferred. So the fundamental question for an economist is the cost of bearing these risks. And the macroeconomic question here is, if you de-risk in some models a lot, you transfer a lot of these risks to the state, is the macroeconomic cost of bearing that cost from the state reduced or not compared to what the private sector can do? And we very often jump to the conclusion that yes, it must be the case. But I would argue that we need to be a little bit cautious of that because it's not always the case. Second big question to me, how much of the aid, the state aid, should be borne by consumers of electricity or by taxpayers? I think it's important to make it very concrete. If you have, on the one hand, a CfD, that's a measure where the payer of the aid, to some extent, is the consumer of electricity, because most of the time this is channeled through the bill, the end-user bill. If you have state guarantees, it's not obviously the consumer paying, it's the taxpayer in one way or another. So for an economist, it's quite important also to highlight that this aid package raises profound questions as to who should pay. Is it the taxpayer? Is it the consumer? And in what proportions? Next question related to that is an intertemporal question. We are almost taking for granted that 40 years is the right duration for a CfD. Who decided that and who demonstrated that this is the optimal duration? For me, I'm just asking the question as an economist. Very concretely, there is a question of intergenerational allocation of the cost of these nuclear programs. I think Laurent mentioned that in his opening. The fundamental question is who should pay, also in terms of timing. This generation of consumers, the next ones, taxpayers. And these are fundamental choices, I think, that the policymakers are making explicitly or implicitly when they design these aid packages in the different countries. Fourth and last question of my second point, are we sufficiently thinking about the robustness and the resilience of these contracting mechanisms over time? A good part of my job is to work on disputes and arbitrations related to contracts which, for one reason, were one day a good solution and the next day turn out to be problematic. And one lesson I've learned from that is that we need to think very carefully from the very beginning as to how these contracts and mechanisms are going to be able to be resilient to shocks in the system, in the market in the future, and to policy decisions. And obviously it's not possible to anticipate these shocks. That's not the point. But the point is to build in these mechanisms, some triggers for reopening, which are well thought, and B, wherever relevant, some indexation clauses, some revoyure clauses, which will allow an efficient evolution of these contracts over time. I would even put it this way, it is necessary to anticipate that because there will be some collective learning here, and it may be that states in the future want to some extent exit as the private sector matures and is able to take on some of these risks. So are we anticipating a case in which, for instance, there would be refinancing and some state exit in the future in some of these packages? And are we building in these contracts the right ways to do it? These are obviously questions for debate, but which I think are fundamental. So this is for my second point on some of the open questions which I think are fundamental. Let me turn to my final point for today. The final point is, having spent now close to 2 decades, as I said, working as an academic and expert on this, what I call the new market model emerging in Europe, which is not just, I would say, a set of markets, but also a layer of contracts and planning mechanisms around it, which we have collectively as academics called hybrid markets. My thesis here that I'd like to discuss with you is that, in fact, these nuclear cases will be a huge accelerator for the emergence of these hybrid markets and will force us in Europe to confront some of the questions that we have not yet been willing to address. Very concretely, these hybrid markets rely on the fact that you need to have some planning mechanisms, including for the long term, that will help the markets to do their job. And I think in Europe, it's fair to say we have the beginning of some planning mechanisms in the energy sector and in the electricity sector, but a lot of that is very short term and certainly not the time frame that is aligned with what we are talking about for nuclear. It's also fair to say that we will need to confront some of the important trade-offs in terms of having a common energy mix. I mean, Guillaume's presentation on modulation highlighted the fact that we need to anticipate cases where nuclear would have to cycle a lot more because we would have done either a lot of renewables or a lot of renewables without enough flexibility to ensure that this is an optimal mix. And again, I'm putting this as a if, but the point is, if we are not good collectively at putting in place these common planning mechanisms, then we are likely to challenge these stated mechanisms in the future. Second thing, the framing of the contracts themselves, the two-way contracts for CfDs. I think we have not discussed another very important thing, which is that the state is a counterparty to these contracts. What that means is, again, that we are re-injecting the state at the center of the electricity system, whether we like it or not just in terms of planning, but also as a counterparty. And to me, this has two consequences. The first one is that the state itself will become exposed to basis risk, meaning that there remains a question as to how the state risk exposure evolves in the future, depending on the difference between the reference price in the CfD and what happens to be, in the end, the market price. And the states themselves will need visibility for budgetary purposes, or will need to hedge their risk. Which leads to the next question, which is what are the tools, the leeways for states to actively manage that risk exposure that they are creating for themselves. And that leads me to my final point. The natural consequence of that is that there will be a convergence of interest between states who want to hedge their basis risk and budget exposure, and the interest of some downstream consumers. There are a number of large industrials, but also other consumers who want predictability on their cost of electricity and on their supplies of electricity. So naturally, I'm coming to the PPA questions and the three-way contracts discussions that have started to emerge in Brussels. I would put forward that the growth of these nuclear state-backed agreements will naturally lead to a range of new state aid questions in the years to come, which have to do with the back-to-back arrangements of states with large industrials who want to access the power on long-term agreements. And I think we already see a number of cases emerging. Again, these are different state aid cases. It's more between a downstream user and the state, but it is also part of industrial policy, and it is also part of the planning of energy policies that I mentioned earlier. So as I said, these are more like open questions for debate, but I hope this can foster a good discussion.